Section 1.10, the coordinate plane. A coordinate plane is formed by the intersection of two number lines. The horizontal number line is called the x-axis. The vertical number line is called the y-axis. Here's what the coordinate plane looks like. As you can see, we have a y-axis, which is my vertical line, and my x-axis, which is going to be my horizontal line. It starts at the center of the intersection, and that is called the origin. And from there, to the right of the origin are our positive integers and positive real numbers. To the left are my negative values. Also from the origin, when we go above the horizontal axis or above the x-axis are all my positive real numbers, and below are all my negative real numbers. This is where we call quadrant 1. It's also named with the number 1, but it's also a Roman numeral 1. Going counterclockwise is quadrant 2, quadrant 3, and quadrant 4. And remember, the intersection of the horizontal and vertical line, or the x and y axis, is the origin. Now, to plot a point, we use ordered pairs. Ordered pairs give the coordinates and the location of the point on a coordinate plane. For example, I have an ordered pair, which is 2, -3. The first number in my ordered pair is called the x-coordinate. Therefore, I move left or right on my coordinate plane first. And then my second number in my ordered pair is called my y-coordinate, which tells me to move up or down depending on how far I moved left or right. And again, as I stated, the first number is my x-coordinate, my second number is my y-coordinate. Let's do an example. Plot the given points and name the coordinates and the quadrant the point is located. My first one is 2, 3. My x is 2, my y is 3. So I go to my origin, I move 2 units right, and then up 1, 2, 3 units. That ordered pair is in quadrant 1. And they also want me to name the coordinates. This is my x-coordinate. This is my y-coordinate. My next ordered pair is a -4, 5. My coordinates are x-coordinate, -4, y-coordinate is 5. And I plot, I go to my origin, I move 4 units to the left, and then 5 units up. And this is in quadrant 2, or the number 2. My next example, a -3, -6. This is my x-coordinate, and this is my y-coordinate. And now I want to plot that point. -3, -6. Go to the origin, move 3 units to the left, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. And that is in quadrant 3. And finally, my last example, I have 4, -5. This is my x-coordinate, 4. My y-coordinate is -5. Plot the point. Start at my origin. Move 4 units to the right. 1, 2, 3, 4. And down 5. 1, 2, 3, 4, 5. And I know that that point is in quadrant 4. As you can see from this example, I plotted a point in each quadrant, 1, 2, 3, and 4. But that's not necessarily the case at all times. So let's take a look at a few more examples to see where points can be plotted on a coordinate plane. My first example, I have 0, 0. This is my x-coordinate. This is my y-coordinate. And when I plot that, 0, 0 is going to be at the origin. I don't move any units to the left or right or up or down. That is my origin. Therefore, this isn't in a quadrant, it's on the origin. Next, I have 0, 5. My x-coordinate, my y-coordinate. And when I plot that, my 0 tells me I'm not going to move any units to the left or right, but I'm going to move up 5. 1, 2, 3, 4, 5. So as you can see, I am not in any quadrant. I am actually remaining on the y-axis. So when my coordinate x value is 0, I remain on the y-axis. If they're both 0, x and y, I'm at the origin. The next example, a negative 3, 0. My x, my y-coordinate, and now when I graph that, I want to take my point, again, starting at the origin, move 3 units left, and then no units up or down. Again, I am not in a quadrant. I am on the x-axis. And when my y-coordinate is 0, I remain on the x-axis. Therefore, I can either be in a quadrant, on an axis, or at the intersection of the two axes called the origin. So you can see, this is how you get to be placed on a coordinate plane. If I am on the x-axis, my ordered pair, the x-coordinate is some real number, and my y-coordinate is 0. To be on the y-axis, my x-coordinate is 0, my y-coordinate is some real number. To be in quadrant 1, my x-coordinate is positive, my y-coordinate is positive. To be in quadrant 2, my x-coordinate is negative, my y-coordinate is positive. Quadrant 3, x-coordinate is negative and y-coordinate is negative. And to be in quadrant 4, my x-coordinate is positive and my y-coordinate is negative. The origin is 0, 0. Let's do a few more examples. In which quadrant does each point lie? Letter A. Letter A does not lie in a coordinate, it lies on the y-axis. Point B. Point B is in quadrant 3. And its x and y coordinates are negative, negative. Specifically, negative 1, 2, 3, 4, negative 2. Next, point C. Point C is in quadrant 4. And you can label these just 3 and 4 rather than using Roman numerals. To be more specific, it's 1, 2, 3, 4, 5, 6 for the x-coordinate, and down 1, 2, negative 2. The next example, write the coordinates of each point. Here I have point A. Point A is at the origin. That is 0, 0 for the x and y coordinate. Point B is on the horizontal axis. I'm going to count to the left of the origin. 1, 2, 3, 4, 5, negative 5, and it does not move up or down, so my y-coordinate is 0. Point C is on the y-axis. It doesn't move left or right, so my x-coordinate is 0, but it moves up 1, 2, 3, 4, 5, 6. My y-coordinate is 6. And finally, point D. It is to the left of my origin, 1, 2, 3, 4, 5, 6, 7. It is a negative 7 units, is my x-coordinate, and it is up 1, 2, 3, 4, 5, 6, 7, 8. My y coordinate is a positive 8. Next, let's name the point with the given coordinates. Here I have a -2, -5, a -2, -5, a -2, and up 5. 1, 2, 3, 4, 5. That would be point C. Next, 6, 0. 1, 2, 3, 4, 5, 6. 0 is point B. Next is a -4, -4. 1, 2, 3, 4. Down 1, 2, 3, 4. That would be point D. And we know the next one is 1, -2. Has to be point A, but just to verify, 1 and then down 2 would be point A. Now what we want to do is to draw a coordinate plane, then graph the points. At this point, you've seen me graph them on a grid that has been already defined for you, and you won't have that available with you. If you need, I can get graph paper to you, but you still have to draw the coordinate plane. To do that, all we're going to do is draw a y-axis and an x-axis. And then I try to evenly space my units the best I can. And I do that to the negative and positive side of the axes. And I do that for both axes. Try to make them evenly as spaced as possible. We're not going to be perfect. On graph paper, it's a lot easier. But if you don't have graph paper, it's going to look similar to this. Now what I do is I graph the ordered pair that's given to me. And here I have a -3, 2. A -3, 1, 2, 3, and then up 2. So I estimate the best I can, and then I'm going to label that point K. That's in quadrant 2. 0, 2. 0, up 2. That is point P. And finally, I have 2, -5. 2, -5, over 2, down, 1, 2, 3, 4, 5. And I'm over 2. Just to specify again, 1, 2, 3, 4, 5, and over 2. And that is point Z. So it's not as specific as if I had graph paper or a grid, but you can do it this way. And again, if you need graph paper, I can get that to you. Next, in which quadrant or axis does each point lie? I've generated a coordinate plane here for you, and now what they've given us is a generic ordered pair. G is going to be x, y. Well, we know that that is my x and y coordinate, but they don't give us any values. They tell me that x is going to be greater than 0. That means x is positive. And they tell me y is greater than 0. That says that this is positive. So I have an ordered pair that is positive x value and a positive y value. That tells me that my point has to lie somewhere in quadrant 1. So that's all we need to do is to determine where this lies by the given information here. H, again, is a xy coordinate, but we know this is an x coordinate, a y coordinate. They give us a little more information. X is less than 0. That means it has to be a negative number. And here, y is equal to 0. So that tells me that it's going to be a negative number, which means it's going to lie here, but y is 0. So that means it won't go up or down. So it's going to lie somewhere on the x-axis. And finally, my last ordered pair is point P. Here my x-coordinate is negative. My y-coordinate is the absolute value of a -4. And we know the absolute value of a -4 is a positive force, so that would be positive. Therefore, my ordered pair would be a negative x-coordinate and a positive y-coordinate. So I would be in quadrant 2.